Okay.
Good morning, everyone. Today I'm going to continue our study on the inference in first order logic. I'll talk about a technique to handle a more general case of clauses. We recall that the forward training and backward training algorithms can only handle the definite clauses, but the resolution technique, which I'm going to introduce today, can handle more general case. First, I'll talk about the idea of resolution, and then I'll talk about how to convert any logic sentences into the conjunction normal form, the CNF. And then I'll introduce you to the resolution inference rule. And then I'll show you how the resolution proof is performed. And finally, I'll talk about an example of such a proof. The idea of resolution is that every sentence of first-order logic can be converted into an inferentially equivalent conjunction normal form sentence, and the proof can process using the resolution rule. So how do we convert the conjunction normal forms? These are the 6 steps. You can read it at home. When you see here, step 4, the scalamized. This is a more general case than the existential instantiations I mentioned in the first section. And I'll talk about a more general case of this operation, how this is performed. Here is an example. We have this sentence in first order logic, and first we should eliminate the implication. We take away the implication symbol, and at the beginning of the premise at the negation symbol, and we replace the implication symbol with a or symbol, and it becomes this line. Step 2, we move the negation symbols inwards, and such operations is done according to the De Morgan rule. You can see when we move the negation symbol inwards, the two negation symbol together and they disappear, and the universal quantifier becomes the existential quantifier, which is consistent to the De Morgan rule. And step 3, to standardize the variables, which means to replace the duplicate variables. Step 4 is what I want to talk in particular. Okay, let's see what the sentence is like before step 4. What we have to do is to handle these existential quantifiers, the one here and the one here. We have talked about 2 inference rules. In the existential instantiations rule, which says that we can replace the variable with one single instantiation, so it becomes this. However, this is wrong. Why? Because we have a universal quantified sentence at the beginning. Let's see a simpler example. Suppose we have a predicate, father yx, which means y is the father of x. And we have such a sentence, which means everyone has a father in this way. And we try to perform scalamized. If we simply replace the variable, the existential quantified variable y, by a single instantiation a, the meaning will be totally different. It means that everyone is the son of a, which is very ridiculous. Instead, we should consider y as a function of x, which means its value depends on the value of x. To express this meaning, we replace y with with the function of x. In this way, the variable y is eliminated. So for the previous sentence, we have, let's see, what do we have before? The sentence will replace y as a function of x and z as another function of x. Which what we get here. And step 5 is simply drop the universal quantifiers and distribute the n symbol over the O symbol over the n symbol. And this is what this is already in the CNF form. And now I'm going to talk about the resolution inference rule. If we have two sentences both in CNF form, and we found that in each of the sentence there is one literal. There is one substitution U which make them opposite. You see the negation. Then we can combine these two sentences and drop these two variables. And if we apply the substitution U to the resulted sentences. Here is an example. We have two sentences, this and this. And we found that by this substitution, this literal and this term and this term becomes opposite. So we can simply drop both of them and combine the rest of the two sentences together to make this. This is how the resolution inference rule works. So how does the resolution proof work? The resolution proof works by proving this sentence is unsatisfiable, which means after several steps of resolution, we resolve, we got empty clause. And then we can say that this sentence is unsatisfiable, and we can entail the sentence alpha. This is exactly the same as the resolution in propositional logic. Here is an example. The first step is to convert all these sentences into CNF. Please take down all the lines and especially the numbers there. I use those numbers for my example proof later. Okay, give you some time to take it down. Now I turn the camera towards the whiteboard. So, how to prove this sentence? We can see that we want to prove that West is a criminal. So we add one more sentence to the knowledge base. We assume that West is not a criminal. And we resolve this fact with sentence 1. And we got this line. And West is an American is true in the knowledge base. So we resolve the resulting line with this fact in the knowledge base, and we got these two lines. For sentence 2 and 5, we see that there is a weapon. M1 is a weapon. And by resolving with the sentence we got in the previously, we got this line. We see that the number of terms get smaller and smaller, and we get closer to what we want to prove. And next, remember this line. This is what we get. Okay, this is not the line we get previously. And by sentence 2, 3, and 4, we show that something wrong. Okay, we can prove that West has sell a weapon M1 to Nono. So West is innocent only if Nono is not hostile to America. Unfortunately, Nono is. Why? By sentence 8 and sentence X, we can prove that Nono is hostile. So these two lines are able to generate the empty clause, and the original sentence is unsatisfiable. So now we are able to prove that West is a criminal. This example shows you how to perform proof on the knowledge base, and this is all for today. The resolution. Thank you.